recording this lesson today because this one's a longer one and it is review, but it has a lot of information that you do use in other things. So I'm gonna record it, and it's not as short as it was yesterday. All right, so we're gonna learn about permutations today and combinations. We've done combinations. We did this with the binomial theorem first semester. It was when we were learning about Pascal's triangle. There was a formula for that we learned first semester. Permutations are very similar, very, very similar. So what we first have to do is we need to recall some things, such as the factorial. The factorial symbol is basically an exclamation mark, but in math we use it differently. So for example, if I wanted to figure out what 5 factorial was, factorial after a number just means that number times every single number before it all the way down to 1. 5 times 4 times 3 times 2 times 1. Bless you. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. And of course 120 times 1 is still 120. Okay? But in our calculators, we have some functions that can do the math for us, because that's what these are for, to simplify things. So if you're using this calculator, you need to hit the 5 first, or whatever number you're taking the factorial of. Factorials have to do with probability, so there's a PRB button, and then you see 3 things, NPR, NCR, and then the third thing there is the factorial symbol. You scroll over to it and hit enter, and then it should appear next to the number that you typed in. 5 factorial is 120. If you're using the class set calculator, this one has it also, okay? It looks a little bit different. See the number 3? On the board of the calculator, right above the number 3, it says X factorial. That's what we want. So you have to type in the number first that you want to take the factorial of, hit second, and then the number 3, and then it does it, okay? The only difference is that it doesn't put the exclamation mark on the screen, but this calculator doesn't do that with anything, okay? So that's how you access it here. If you're using a Casio, I think it's around the same spot. I think the Casios also say X factorial, and I think you have to hit the shift button and then wherever that is.
It's at the top right here.
Okay, so towards the top, this area, yeah, but it's also X factorial, right?
Yes.
Yeah, okay, yeah. So if you're using the Casio, you hit shift and then wherever the X factorial button is, but you have to type in the number first, okay? So you can use your calculator. First semester when we were doing these, I made you do them by hand the long way. I showed you minimal things on the calculator, but today I'm going to show you everything that you can do on that calculator. So all the shortcuts come today. So permutations, this is what's new. They are an arrangement of objects in which order is important. Order matters with permutations. We didn't learn permutations last semester. We did learn combinations last semester. Combinations have to do with Pascal's triangle. Order did not matter with combinations, but with permutations, order does matter. Okay? It's a huge, huge difference. So when we're coming up with an arrangement, when we just have a list of things like you're setting up 10 kids in a photo. You want to take their photo, but you want to line them up in a special order. Well, if there's 10 of them, then to arrange them, you would just put whatever that number is, factorial. So when we write this in general, n factorial, you take your first number times the next smallest number times the next smallest number. You keep subtracting 1 all the way down till you get to your 3, 2, 1. Okay, this is just in general, just like I did up above with the 5 factorial. A number times the next number beneath it times the next number beneath that, where you're just subtracting 1 until you get down to 1. Okay, all right, so the formula for a permutation is NPR is equal to n factorial over n minus r factorial. Okay, so this is the formula you're going to use. And I'm going to show you how to do it the long way first, But there is a feature in your calculator that lets you just type it on in and boom, you're done. It's kind of nice. It's actually not kind of nice, it's really nice. So example 1, we're going to consider the number of permutations in the letters in the word July. How many letters are in the word July? 4. 1, 2, 3, 4, none of them are repeating. We need to figure out in how many ways can we rearrange. So we're trying to figure out how to arrange them. So we're looking at all of the letters. So there were 4 letters. When it's just an arrangement, you don't need to use the formula, because it's really going to be, since there's 4 letters in the word July, it's just 4 letters arranged. So it would be 4P4. And then you plug all these in. But anytime it's the same number, it just ends up being that number factorial. It's just an arrangement, a pure arrangement. So maybe I'll add that. This is just a pure arrangement of all of the items. When it's just a pure arrangement of all the items, it's just that number factorial, okay? Now 4 is small, so you could type in 4 factorial in your calculator, but this is really small. It's easy to do by hand. What's 4 times 3 times 2 times 1? 24. So there's 24 ways that we can rearrange the letters in the word July. Okay. Then it says 2 of the letters. Now here's where we're going to need to use the formula. So there's 2 that we are permutating, that we are arranging out of the 4. So when we set up our formula, it's going to be 4P2. Okay, I'm going to show you the long way, because you do need to know how to plug it into the formula. But I'm also going to show you the shortcut in the calculator. So first let's do it the long way using the formula. N is always the total number of things that are being arranged, and R is always the number of things that are being arranged out of the total. So it's 4P2. So N factorial, so that would be 4 factorial, all over N minus R factorial, that's 4 minus 2 factorial, okay? And when we simplify this, I focus on the denominator first. 4 minus 2 we know is 2. I would keep it 2 factorial. And then whatever is down here is going to drive how I write the top, because I don't want to write out every little thing. I'm just going to go 4, 3, and then stop at the 2 factorial, because then I can see that something happens with the 2 factorials. What happens?
They cancel.
They cancel out, right? And so what's the answer? 12. So there's 12 ways to permutate, to arrange 2 out of the 4 letters of the word July. Okay, now in your calculator, it's really cool. So remember that PRB button? See, it has the NPR. That's what we're using, our NPR formula, right? Now when you type it in, you have to type in the first number first, your N. Then you hit the PRB button, and you make sure that you select the NPR, and it should put that on your screen, and then put the 2 for your R, and then you hit equals. And it should do it right there for you, okay? In this calculator, it's been a while since I've done it on this one, it's the same type of situation. I gotta find the NPR. It's where the number 9 is. You guys see it? Okay, so you have to hit the 4 first, just like I did on the other calculator. Hit second, and then 9, and then 2, but then you have to hit equals, and then it does it, okay? The Casio should be similar to this one. You just have to find where the NPR is on your calculator. It might be on the board, it might be with a PRB button.
It's on the multiplication and division.
Oh, it's on one of these functions?
Yeah, it's on there.
Okay, so you hit the second button in that, just like this one. Okay, so same way to type it in, but it's just in a different location. All right, cool. So that's your shortcut. So technically, I don't really need to see all this work in the middle then if you're using your calculator, because you're typing it in and you're getting it straight to the answer. So for these ones, I'm not going to expect to see work, because I'm going to expect at this level, you're going to use your calculators, right? Yeah, it's way quicker. All right, so example 2, 10 students are competing in the finals of a spelling bee. So we've got a total of 10 students competing. I need to remember that, because that is the N, okay? Top 3 spellers are awarded first place, second place, and third place. So because we're looking for the top 3, order matters because first place, second place, and third place are not equal. If you're getting first, that's better than getting third, isn't it? So order does matter. So anytime order matters, this is a permutation. Order matters. So, letter A, is the order in which the competitors finish important?
Yes.
It sure is. And I don't think we need to really explain that in words. We know that, yeah, first place is not the same as last place, that's for sure. If you're earning a placement in the top 3, that means you were one of the top 3. That's important. All right, so letter B, how many possible ways are there for first, second, and third place to be awarded? Well, there's how many students total? 10. And how many places are being awarded? 3. So 10P3. The top 3 spellers, that is our R, okay? So we're using 10P3. So you can do it out the long way, but we've got a calculator here, so you just have to type in 10, find your NPR button, and then 3, and you're just gonna type it in and get your answer. It should be 720. Okay. So there's 720 ways that they can come in first place, second place, and third place. That's a lot of ways. A lot of ways. You really gotta make sure you're showing your skill to reach one of those places. Does anyone need me to see it do it the long way? No? Okay. It's just plugging it into the formula and simplifying it. On the next page, we got our third example there. It says, look at the word bow wow. The letters O and W are repeated. Thus, the letters in the word are not all distinct. This is key. The letters are not distinct. We've got repeaters. So this is an example when we have repeats of something. We've got repeats of the letter O. We have repeats of the letter W. So when we figure out the arrangement of these letters, how many ways we can arrange them, it's a little bit different than just rearranging the words July, because J-U-L-Y, those were all distinct. They were all different letters. So that's going to be different than this example. So letter A, how many permutations of the letters in a 6-letter word would there be if the letters were distinct? So let's pretend that there are no repeats. So I'll put in parentheses, no repeats for pretending. Well, if there's 6 letters, then it's just a pure arrangement, so it would be 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, but we can use our calculator for that. So finding the factorial key, what should we get? 720, right. So there's 720 ways that those letters can be rearranged, okay? Well, how many permutations of the letters are there in the word bow wow? Well, we have to be careful because there are 6 letters, right?
Yeah.
So we are going to have the 6 factorial, but we have to divide out the repeats. So letter O has how many O's are there? 2. So we have to divide out a 2 factorial. And then W repeats. How many W's are there? 3. So we have to divide out a 3 factorial. Okay? So there's a couple different ways that you can go about this. For some of you, it might be easier to just do it by hand. The numbers are small enough. For some of you, it might be easier to type it into your calculator. I'm gonna try it in the calculator. The only thing is when it comes to the denominator, when you type it into your calculator, depending on the calculator, like mine for sure wants parentheses around that, okay? So we just gotta be careful. So let's see, I'm gonna have 6 factorial divided by, and I'm using parentheses, 2 factorial. You don't need to put times because this calculator recognizes that next 2 items mean multiplication. So I'm just going to put 3 factorial right next to it, okay? And it should do it. It should equal 60. And it does, okay? Now this calculator is going to be the test because this one's the tricky one. So on this one, here's how I would do it. I would go 6, second, 3 to get the factorial. But then you have to divide, remember. You have to divide by 2 factorial, so divide 2, second, 3. But then you have to hit equals. And then you have to divide by 3, second, 3, hit equals, and it does it. So you have to divide each one out one at a time when you're doing this calculator. So it's going to equal 60, okay? But let me show you by hand how easy this is also, because these numbers are small. We know that 6 is just 6 by 4, 3, 2, 1. Okay. 2 is just 2 times 1. 3 factorial is 3 times 2 times 1. And so it's just a matter of canceling stuff out. The 3, 2, 1s cancel. 2 can cancel out with the 4. 2 goes into 4 twice. I could have canceled it out with the 6 instead, but you can't do both. It's either one or the other. Once it's canceled, it's gone. And then 6 times 5 is 30. 30 times 2 is 60. So we still get the 60 ways. Okay? So you do you. Do what works best for you. Okay? On this type of one, I guess it just depends, because it's really the same amount of time in my opinion. But I have a tendency to prefer to write those ones out. Okay? And then multiply at the end. So you do you. Do what works the best and most efficient for you. All right, example 4. There are 8 swimmers competing in the finals of the 100-meter freestyle event. Ribbons are awarded first place, second place, and third place. So does order matter?
Yes.
Yes, order matters. We're coming in first, second, and third. How many swimmers are there total?
8.
8. So that's our N, okay? And we have a first place, second place, and third place. So what's our R? 3, right? R is 3, okay? So suppose the swimmers are equally skilled and each has an equal chance of winning, so the playing field's pretty even, okay? So now it says, in how many ways can first place, second place, and third place be awarded? So that would be, what P what?
8P3.
8P3, right? And we can just type that into our calculator, 8P3. So I'll use this one this time. So I have to hit 8 first, and then I need the NPR button, so second, 9, and then 3 equals 336 ways should be what we get. Okay. Caleb and Ronnie and Jose are swimming for the same team. In how many ways can these 3 swimmers finish in the top 3 places? So this is 3P3, which is really just 3 what? 3 factorial, right? So 3 factorial is just 3 times 2 times 1. I'll just do this one out, so it's going to be quicker to do it here instead of pulling out the calculator. What does this equal? 6. So there's 6 ways that Caleb, Ronnie, and Jose can finish in the top 3 places, okay? Then, what is the probability? Now we're asked about probability. Well, that is what this unit is about, probability and stats. So what's the probability that Caleb, Ronnie, and Jose will finish in the top 3 places? Okay, so remember what probability is. We are looking for the number of favorable outcomes out of the total number of outcomes. That's what probability is. Like when you're trying to find the probability of getting a heads, when you flip a coin, there's 2 outcomes, heads or tails. You want heads, that's one of the outcomes, that would be 1 out of 2. Well here, what are our total number of outcomes? How many ways? 336. And how many of those ways would be Caleb, Ronnie, and Jose getting first, second, and third? 6. So 6 out of the 336. And actually this reduces because 6 goes into itself once and it goes into 336 56 times. Because anytime you have a fraction, you got to reduce it. So it's 1 out of 56 chance. Although most of the time when we're doing a probability, we look at the decimal or the percent. So if I move this decimal over twice, that is a 1.8%. So is this likely to happen? No, it's not. Okay. Well then, what's the probability that Jose will finish first Ronnie will finish second, and Caleb will finish third. Well, this can only happen how many ways? One way. There's only one way. Jose is finishing first, Ronnie's finishing second, Caleb is finishing third. That can only happen one way. And that's this one way. Out of how many ways total? 336. Well, we don't need to reduce that fraction, do we? So we've got some very slim chances here. Very slim chances. It ain't gonna happen. All right, so that's permutations. Combinations, this is review for you guys because we did combinations in first semester. You learned this formula, okay? This is a selection of objects. We're selecting things out of a total, but order is not important. The order doesn't matter. There is no first, second, or third place with a combination. You're just selecting things out of a total. How many different ways can things be selected? Okay, so here's the formula for this. NCR is equal to n factorial over n minus r factorial. Again, we learned this first semester when we were learning about the binomial theorem, Pascal's triangle, okay? And in our calculator, remember where we were pulling up the NPR? Well, NCR is the very next one. So you use this one for the combinations. And on this calculator, the NCR should be nearby the NPR. Here it's on the number 8. So I'm assuming on the Casio, it's where the...
It's on the division.
It's on the division symbol. So is the other one on the multiplication symbol? Yeah. So that makes sense. Okay. All right, turn the page. Our last set of examples. Example 4, a taco bar has 9 different toppings available. Okay. A double topping may not be ordered, so we're not doubling anything, no repeats. How many different 3-topping tacos are available? So there's 9 different toppings, so that's our N. What's our R? 3, yeah, 3-topping tacos, so that's our R. So this is a combination, because the order doesn't matter that you put the toppings on a taco. So it's gonna go 9C3. And I'm gonna go ahead and not put it into the formula because we did that first semester. We're just gonna use our calculator. So 9, and then hit the PRB button, scroll over to NCR, hit enter, and then the 3. Should look like this on your screen. Same if you're using a Casio or even a different Texas Instruments, it should look the same. Should be 84. Is that what you guys are getting?
Yeah.
So there's 84 tacos, different taco combinations that we could create, okay? If you're using this calculator, it's the same way you did the NPR, so it would go 9, second, 8, 3 equals. Exactly the same order. So this is one of the only things in this calculator where you actually follow the order that it is on paper. Remember with the trig, it was backwards? So, yeah. That's why I don't really like that calculator, but it still works. It does the job. All right, number 5, it says there are 12 players on a basketball team. So automatically I know that my N is 12. Coach Siriano chooses 2 players at random before each game to be team captains. So what does this 2 represent?
R.
The R, right. What is the probability that Mike and Tyler will be chosen next game? Mike and Tyler are unique individuals. They're the only Mike, the only Tyler on the team. So them 2 being chosen for the next game can only happen once, right? All right, so keep that in mind. Letter A, does the order matter in this situation?
No.
No, it doesn't. Because the team captains, they're equal. So the order doesn't matter who's chosen to be the first team captain or who's chosen to be the second team captain. It doesn't matter. Letter B, how many ways can Mike and Tyler be chosen to be team captains? Well, Mike and Tyler are how many people? 2 people. So it's just 2 choose 2. 2 people and choosing 2 team captains. 2 choose 2. Well, we can use our calculator for that. 2 NCR 2 is going to equal 1. So there's only one combination, one combo I'm going to put. It's one way that that this can happen. All right. How many different combinations of 2 players are there? Now that's going to be overall. So what would be the NCR here?
12C2.
12C2. Right. So we use our calculator for that. 12 NCR 2. And what are you guys getting? 66 is right. So there's 66 combos overall. Okay. And now we need to find the probability that Mike and Tyler will be chosen as team captains next game. Well, that can only happen one way. Out of how many total? 66. So is it likely to happen? No. It's not likely. It'd be cool if it did. All right, and then our last example, Casey has 15 movies on a shelf. Okay, this tells us something. This means that this is going to be what letter? The N, right. Among them are 3 movies that compose her favorite trilogy. What do you think this is going to be?
R.
The R, right. That makes it so easy the way they word these. If she chooses 3 movies at random to take with her on vacation, what is the probability that she takes all 3 movies from her favorite trilogy? Well, first of all, the first thing we need is the overall total. So what NCR would be the overall total? Yep, 15C3. So 15, PRB, the NCR, the 3, what are you guys getting? 455. So there's 455 combos of movies, taken 3 at a time. Okay, and now we're looking at her picking the 3 movies that she likes from her favorite trilogy. Well, a trilogy is 3 movies, right? And she's picking 3 movies, right? So what NCR would that be? 3C3. Based on what happened up here, what do you think it's going to equal? Right. Now let's verify it. And it does. But can't we make an assumption now? So what's 5C5? What's 10C10? Right. So anytime it's a combination and it's the same number for the N and the R, it's going to equal a 1. So when I find the probability, what would the fraction be? 1 out of 455. Is this likely to occur? No. Not at all. All right, so for tonight, your homework is right here. You can see it nice and clearly. It's not the fuzzy black and white, scanned copy. It's these 8 problems. Here's number 1, and it's through 8 problems on the back of that page, okay? So we get out at 46, so we have some time, so no packing up yet, so at least get a couple problems done before you leave, and then it does go on the homework record, and I'll check that tomorrow. Are there any questions?